So Erik from EPRI is going to be chairing this session. Erik is also the co-chair of our one of our working groups on system operations and market design. He co-chairs that along with Aidan Tui of EPRI, focusing on the market design part. So let me go ahead and turn it over to Erik and go ahead and get started.
All right, thanks, Charlie. So long breakfast, late night, but we're all okay here. We'll get started. People will come in. So we've got a great session today. One of the great things about this workshop over the last several years is, has been bringing, kind of two different areas of expertise together to learn from each other, to try to kind of learn each other's vernacular, and that's been on the, operations, electricity markets, and with the meteorology community. So we're kind of, starting to do some of that, and we're seeing, more of that in some of these other areas where we're, kind of bridging across different levels of expertise. I was involved in some projects where we, really focused on bringing the wholesale markets, ISO folks together along with the distribution system folks. And, they would have certain terms that meant different things as soon as you went from one side to the other, and just saw the importance of being able to improve the communication, learn what each other's doing, and kind of see what the challenges are from the other side. So we're going to do a little bit of that with this session here today, where we have 5 great speakers, covering wholesale markets, bulk power systems, distribution systems, software, third-party aggregator perspective, all sort of looking at, what's the current status of these distributed resources that are providing services to the bulk power system. So one of the questions I'll ask later on is whether folks have any opinions on whether a DER aggregation and virtual power plant are the same thing, or are they different. Maybe we'll hear some different opinions on that throughout. But in any case, we'll get started right away. So our first speakers are going to tag team a discussion here for California ISO and what they've done, both from the markets and implementation side as well as the software side. So Jay Jones is a senior advisor with market technology support at California ISO, and Ashmin Mansingh is the global vice president of engineering with Siemens Grid Software. So they're going to join together and talk a little bit about what's been happening at California ISO. So I think, Jay, you're going to get started.
Good morning, everyone. My name is Jay Jones. I've been at the ISO for approximately 17 years. So I've seen a lot of change in those 17 years. So a real brief history of what we do at ISO. We manage the power grid for California. We oversee the transmission planning process, and we also run the wholesale market. Recent years, starting in 2014, we expanded our wholesale market services to other entities in the West through our EIM program. And in 2019, with the wind down of peak RC, we assumed the role of reliability coordinator with SPP in the West. So we're also also known as RC West. So over the last couple of years, the state of California strategy for increasing renewable participation has incentivized a substantial amount of DERs within the state. So what that's done is it's changed our load patterns. In the good old days, traditional days, the load started out low in the morning and it peaked in the late afternoons, and it repeated that process, on and on and on. What we've seen with the penetration of DER resources is a reshaping of our load curve. So in the morning, starts off low, then in the middle of the day, as solar ramps up, it sort of flattens out and rolls out, And then at sunset, when solar goes away, it peaks up again. And so that shape is the back of a duck. And so thus the duck curve that some of you may have heard about. Our utilities, our load serving entities, have started to utilize some of this excess generation to serve their own loads. And they're also probably going to want to include distributed energy in their RA capacity planning. So as we integrate these systems, it becomes more and more important that we figure out what is the best way to manage these distributed resources. This slide here just shows a brief history of all of the application enhancements we've done with Siemens over the last decade or so. And I'll cover more of those a little later. So where are we with DER resources? So the ISO started integrating DER resources way back in 2005. So as it stands today, we have about 500 plus DER resources generating about 2.2 gigawatts. Those DER resources follow the same interconnect process as a commercial grade resource. 2010, we expanded DER resources to include distributed resources, which account for about 1.7 gigawatts of power through our PDR programs and our RDR programs. So our PDR program, Proxy Demand Response program, required that we modify our settlements process. So before DER, our settlements process was pretty straightforward. You have your load, you have your generation, you have your energy charges, you have your AS charges, pretty straightforward stuff. But with DERs, in addition to managing the grid, we also had to figure out better ways to settle these resources. In 2016, we modified again, or we added our ability to handle distributed DER resources down to 1 megawatt in size. And we modified how we register these resources, bring these resources online at the ISO. So when a new resource comes online, we require that they work with the utility to ensure that they are meeting the minimum qualifications to plug into the grid. So this slide here is how the ISO has met the requirements of FERC 2222. And a lot of that was accomplished based on what we did back in 2016. Now, I won't go through each one of these steps, but the highlights, because the important parts are how we manage our AS resources. So when I say AS resources, it's the spin, non-spin resources, reg up and reg down. So we're providing those AS services as another product from our market based on the DER resources. I'll give you a moment to kind of read through this. We've also, in 2016, we started off with a minimum megawatt of 500 kV. And so in meeting FERC 222, we lowered that threshold from 500 to 100 kilowatts. So back last year, May 18, 2023, FERC accepted our filing to modify our tariff, making us the first ISO to fully enable the distributed energy resource aggregation goal of FERC 222. So this year, November, we're going to modify our tariff completely so that it is in line with FERC 222. One of the big changes, as I mentioned before, is lowering the threshold for participation from 500 kilowatts to 100, allowing for a more heterogeneous mix of DER resources. And my colleague, Ashmin, will go more into the heterogeneous changes to our models needed to pull that off. One of the big items was that we clarified that we did not want to have double dipping. So double dipping or double compensation is participating in a retail program and at a wholesale participation for the same set of resources. So with all these new DER resources online, we are seeing the impact. So this graph shows the impact of cloud moving across ISO in the middle of the day in January. So with all of our solar DER resources online, we saw a 700 megawatt plus swing in our load. And that was strictly caused by, the cloud cover. So one of the challenges is how do we manage these DER resources and operate the grid? As you can imagine, it comes down to situational awareness for our operators. As the previous graph showed, the behind-the-meter resources can, and they do, impact the load throughout the day. And weather events have a real-time impact on operations. As more DERs come online, we're going to have to start dealing with the bidirectional nature of these DER resources, particularly when you see when batteries start to discharge and charge in the middle of the day. So it becomes more important that our operators are aware of what's happening with these resources and that they have the appropriate technology in place, and our forecasts are responding quickly to these changing events. So one question that comes up is, if DERs are so wonderful, why hasn't there been more participation? One reason is retail is more attractive. NEM programs, net energy meter programs, they're easier. Standalone requirements are too low. 500 kV for generators and 100 kW for storage. We don't have a good methodology as of yet to determine what is the RA capacity for these DER resources. There's been a lot of discussion about, how do you do RA, resource adequacy, and DERs. And finally, the complexity of bringing DERs online and the planning process, and also working with our distribution partners or our utilities. With all that said, in about 2 months, we will have our first DERA participating in the ISO markets. So moving forward, our key challenges from the previous slide: forecasting and the impact of forecasting on the impact of these DERs forecasting on the actual load. Tied to those forecasts is capacity planning. Capacity planning and also procuring capacity at the most efficient cost. And also, because remember, we're managing a power grid, allowing for capacity at a good cost that is reliable. And then what are the long-term impacts of adding additional DER resources to our planning process? I think some of you have heard that there's a backlog of resources in the queue to be brought online, and so that's one of the challenges that we're facing. And back to situational awareness, we need to figure out what is the best way to manage these DER resources with our system operators and our utility partners, so that we are in alignment when systems change in real time. So I'm going to pass it over to my colleague at Siemens, Ashmin, with more details.
Thank you, Jay. Good morning, everybody. So when Erik asked me to talk about, what are the software changes or what are the system changes that are needed for this. So I thought about like the four core areas, right? Infrastructure, which is how do you model the data, what models you build, what are the market clearing software that is the scheduling and the pricing part of it. And then there is the part that is the reliability, which is the SFT, power flow and contingency analysis, and how the communication and everything happens, right? So this is the broad structure of the software that makes this thing work. So what you see here is that structure at two different things. With any other traditional generator or any other participation, with this, there are two different things that stands out. One of them is called as a location. That, these resources, they can be aggregated across multiple pricing node. In many places, they call it as EP node, P node. And so they can be connected into different pricing node, yet aggregated. CAISO has this approach because they're all within the same sublab, and the premise is, or the assumption there is that within the sublab, all the pricing nodes, the price don't vary that much with each other. However, if the problem with that is if there is a binding constraint that comes in between that, then either they can prorate it or they can create separate sublab. There is also some ISOs are thinking about doing a single node aggregation. Single node aggregation is much easier because you have just one node to manage, but it has its own challenges also, which is you might not enough resources to meet the 100 kilowatt or whatever threshold you have. The other challenge could be is that the aggregation, as long as they're bidding or injecting power into that network as a single bid, it's okay. But if you have all on a sudden get to a point when you have multiple bids injecting into the same node, having the same shift factor, all of a sudden you see that your transmission constraint will have more non-zero terms, and hence it will create the challenge. So both approaches, depending on how you take it. There is another different aspect, which is this telemetry. All of us know who have worked with this that we need for the situational awareness, the telemetry. CAISO has told that if it is 10 megawatt or they're providing ancillary service, they have to provide the telemetry. And otherwise, they are self-managed, irrespective of whether the fact is that they have a storage or not. Ancillary service, we all understand. We want to know where it is dispatched, how much is left, and all that. And so that is one aspect of it. State estimator can see those points depending on if they are modeled in the non-observable part of the state estimation. Nearing telemetry helps in that process, but I think state estimator need to see a little bit more into that area to detect what is really getting injected into the network. So overall structure. Let's talk about different models, because where we are today is part of the journey that Jay talked about. And so there are few models that are available currently, and these things can use them. We have the PDR, proxy demand response. The reason it is called proxy, because it is modeled like a generator. We started with a 5-minute proxy demand response. Now it is hourly. So CAISO has this process called as HASP. We can basically, schedule in that. By the way, one thing I want to also tell that CAISO runs a multi-interval ramp coupled dispatch, look-ahead dispatch, as well as two processes to do the real-time unit commitment and short-term unit commitment. They run in synchronous with each other. So all these resources, get through that orchestrations. Reliability demand response is another one that the operators can bring in when they need it. The participating load is very interesting model. I have not seen much participation, but it is a very good model, and we learned a lot from that. It's basically is a mirror of a generator on the other side. Similar constraints like startup, you have the minimum uptime. Other side, it is the curtailment, minimum curtailment time, curtailment cost, variable cost, and all that. And when we developed the model, we didn't really know that what the value is. But when we came to managing the storages, we realized that we can reuse many of that model. There's a pattern basically emerges. The non-generating resources that is heavily used now, there are two flavors of that. One is called lesser, limited energy storage resource, and the other is called as or REM, non-REM. The distinction. The REM can provide regulation. So imagine when we started doing the simultaneous co-optimization, there was these rules in the market that says energy and regulation must be together. The variables are linking. But with REM, you don't have to. And the reason that helps that is that these are self-committed resources. They don't have a commitment variable to link the energy, so hence you can model them very easily. Non-REM can provide anything, energy and regulation. We have gone through a series of refinement for the energy storage resources. We started with modeling a flywheel way back in, I think, 2013, 2014. But today we have 16 gigawatt of storage in CAISO. The entire regulation is now procured from the battery. So I've gone a long way, and those models exist for anything. And hybrid is basically the combination of different DRs that we can put on an injection point, and we can limit them there. So pattern-wise, one pattern that is dominant, that is this NGR pattern. You can have the DDR, which is the dynamic demand response, which is on the load side. So CAISO's ADER is basically a combination of these three things, and we'll see that very soon. But with NGRs, the ramp rates can be different for both sides. Okay, one thing I want to tell, why do we call it NGR? So what we have done is that we have created two abstract model. One is called as MSG, and other is called as NGR. So what does MSG means? Any generator that has multiple states can be modeled in that pump storage, batteries, combined cycle, and all that. NGR is a similar abstraction that you can, basically it's a data-driven model, and it helps to quickly adapt actually. When you build models, mathematical models like that, it has ramps on both directions. The ramps can be multi-segment because, there are batteries now coming, they say that, well, I have a parabolic curve and you need to model, at least give me 2 segments on both directions. So that's the reason why they can be multi-segment. But otherwise, they have, range on both sides, and the price curve for these things is in the first and the third quadrant, and you can, basically optimize them. Key functionality that helps with the battery storage is this huge SOC model. Basically, as I told you, limit of activation, how many times you want me to charge, how many times you want me to discharge, how many times daily you want to run, how many, if you want to curtail me, what's the minimum size, and things like that. These models are built, for example, for 1 megawatt, but they can be scaled down because these are continuous models. There is not much discrete states are there, so you can adapt it down pretty much. The batteries, what enable them to adapt to the ancillary services and is the state of charge that can be managed at the beginning, at the end. And if you are awarded with the ancillary service, we can protect the state of charge so that you are not depleted when you are to go provide the ancillary service. So all these constraints, these are in production for last couple of years and doing well, I'll say. So this is ADER. So this is what CAISO has proposed. So it has 3 things. You can see there is a generator, there is a curtailment resources, and there is storage. So they're connected to different pricing nodes, and they're part of the same sublab. They provide a single bid. The single bid goes to the market optimizes it, and market sends what is called as the DOT, dispatch operating target. And it sends the DOT to the scheduling coordinator. Now, how the scheduling coordinator distributes to them is It's probably their responsibility. You see these participation factors. The participation factors are used to distribute the award for that single bid that comes as injections so that we can see these things in the power flow. A few things that are still kind of developing is that how do you model the outages, for example, or how do you rescale the DFs if one of the node goes out? But we'll kind of like figuring that part out. Yeah. Oh, sorry. Yeah. So this is the last one. I just want to tell this that we just get the meter data for the settlement, submit the bids, market clears, provides the schedule. Maybe in the future there will be little more connection that markets can provide the schedule to the distribution utility because they have a much bigger role into this. I'll stop. Thank you. If there is any question, I'll take it. Thank you, Erik.
All right. Thank you, Jay and Ashmin. So next we have Dylan Cutler, who is the head of product at Camus Energy. So Dylan, I think, is going to kind of go more maybe on the distribution side of things, talking about some software of, maybe covering some of those distribution operations and planning complexities that Jay kind of briefly mentioned and how we might be able to address that.
Yeah, so I think that's exactly right. I'll try to drop a little bit more into the distribution utilities perspective on this, focusing on how that supports aggregator participation in the markets. So just to frame a bit the challenge that I kind of wanted to speak a little bit about is, as we just kind of covered with the CAISO talk and example, there's the ISO RTO markets. There's these DER aggregations that we're hoping to support bidding into those markets. And then there's this other piece down below, right, that all of these are located in the distribution system. Maybe they're solar, installations behind the meter, electric vehicles, what have you. And so this question arises, what about those distribution system assets? And what impacts do these aggregations have on those as they're bidding into the wholesale market? And so really the challenge that we're kind of seeing is some of the ensuring reliability and maintaining power quality in the distribution system. How do we do that while enabling the effective participation that FERC 2222 aims to support? And so this brings kind of new challenges around information and data exchanges. So kind of this frames kind of those different parties and kind of what pieces need to interact more effectively. This graphic is kind of reworked from Australia's done some work on this, kind of leading out, I'd say, in some aspects. This is from AMO's Project Edge work there. And so these are some of the higher level requirements that kind of surface as you start to think about these data exchanges. And really it's integrating DER registration and telemetry and market activity. So how does that information move from the aggregators? Obviously it has to go into the ISO, but how does it also move around to the DSO or the distribution utility? I'll come back a little bit to the operating envelopes concept. This is something that Project Edge work focused on a bit, but it's one way to kind of communicate limits while allowing flexibility in the bidding to the wholesale market. The coordination of market and grid services kind of between the utility and the transmission operator. So that gets a little bit to the double counting kind of challenge. How are these services kind of coordinated? And then this data exchange challenge that hopefully will enable effective scaling. So I'm kind of basing a little bit of this discussion on work we're doing with a couple IOUs in the PJM market. So this is out of their submission to FERC on how they were going to address this challenge. And here they've outlined basically a market agent that's going to be doing the bidding, a dispatch agent that's kind of responsible for dispatching against the market signals, and executing overrides that may come from the distribution utility down to these DERAs. And the kind of fine print down here actually notes that sometimes these can be the same entity, right? The market and dispatch agent may be the same entity. The utility and the dispatch agent may be the same. They might all three be the same. So it doesn't force these to be separate bodies. That's kind of left to the PUC and utilities to sort out a bit. But and I will note that 2222 does speak to these requirements around these communications, both operationally and in the registration phase. So this is stuff everyone's kind of having to deal with. But first, I did kind of want to step down one level into the kind of distribution system because a lot of this effectively delivering on those kind of communication paths starts kind of at the bottom, in my opinion. These are challenges that we have seen kind of at the distribution system that impacts how effective this can be. So this isn't, every distribution utility doesn't look like this. Some have different pieces and parts, but this is kind of trying to generalize this. There's a bunch of acronyms on here, so I'll try to go through it relatively quickly. But starting at the top, there's kind of most utilities have some sort of distribution management system, DMS or ADMS. That's often talking to their distribution equipment, kind of on that far side, the telemetry and control, sometimes often passing through SCADA and integrated into that DMS system. As we move kind of to the right, there's AMI and smart metering infrastructure. And then you move over into kind of the traditional CNI, maybe demand response resources behind the meter DERs. Those often interface with some sort of distribution energy resource management system or DERMS or a DRMS, kind of those pieces come into play. And then the front of the meter resources, those sometimes actually can be tied in through SCADA, but those also sit there in the DER space. And then you've got these aggregators that are starting to emerge, and that kind of path out into the ISO. And then additionally, you've got your kind of GIS and connectivity that's defining kind of how the whole distribution system is connected. So these are pieces out there in existence, but we're seeing kind of a few key gaps between these DERs and the DERMS and that central kind of, operations part of the distribution utility. And so those often sit kind of in separate parts of the utility. A customer programs group might be kind of in charge of recruiting customers, and they have a DERMS that kind of dispatches all of those resources, but there's really no communication into the operations side of the utility. And they don't see exactly how that's impacting the distribution system itself. And then typically there's little or no collaboration with aggregators at this point. And so, we generally see a need for increased data exchange and coordination between these elements to effectively allow for these DERs to be exposed into the ISO and RTO markets while not causing kind of challenges for reliability at the distribution system. So that's kind of a key challenge at the foundational level to let these, maybe some of the things that Jay and Ashmin described about, how do you encourage these DERAs to actually participate? And is that maybe a challenge with the local utility? I'd maintain that, yes, probably it is. There's a hesitancy with the folks we work with to kind of go forward on all of this aggregation and participation without knowing what it's going to do to their distribution system, because all of a sudden these things may be operated for totally different objectives than they've seen in the past. So I was going to talk just a little bit about kind of what does this look like, speak to a couple use cases that we're working on right now that kind of lead into that future model. And also trying to tie a little bit to kind of the forecasting side of the house here. So, because it is an important ingredient. So kind of you've got some of those base ingredients, AMI, GIS and connectivity, and SCADA kind of all the way on the left. Pulling the AMI into a forecasting service, essentially, combined with a lot of the kind of NOAA products that are out there and available to, kind of to the discussion yesterday afternoon, pushing those through different types of machine learning, kind of gradient boosting algorithms to look at meter level forecasts across the entire distribution system and behind the meter forecasts. So you kind of have that ingredient. Additionally, at the bottom, pulling from kind of the system of record at the distribution utility, establishing the essentially power flow models for all the circuits in that distribution utility. And then pulling those together, pushing that forecast through the system models, really to start to align kind of how the distribution system it moves from like a now operations kind of focus to a day ahead view that can kind of align with how these people need to be bidding a lot of these aggregations into the wholesale market. So starting to provide a view of what that distribution system will look like and where its constraints will be over the next 24 hours and then some. And so those kind of combine into these operating envelopes of kind of an export and import limits that can be communicated either directly back into the utility, through communication into their DERMS or direct control of front of the meter resources, perhaps, or outbound to the aggregator. And so these are a couple of kind of use cases starting a little bit smaller. And so this is looking at deferral for distribution transformers. So this is kind of some work we're executing on to activate managed EV charging to preserve or extend the life of distribution transformers. This doesn't require all the kind of power flow models that kind of we looked at in the last slide. This can just be aggregation of forecasted meter loads up to that transformer level and understand the remaining capacity and how much EV charging kind of is available and when you may need to curtail some to avoid excessive overloading for extended periods of time. So that's one piece there. This is something that can be, almost, you generate that operating envelope that limits the curtailment, and then it can be self-consumed and directly managed depending on how that customer program is set up. Another kind of baby step towards this larger kind of interaction between aggregators, DSO and ISO is, again, more on the self-consumption of these operating envelopes, but it's that stepping stone is flexible interconnections. This graphic in the top is one from EPRI, where they kind of show a little bit about that if people aren't familiar. It's kind of the concept that you could connect more DERs or larger, say solar installations at a certain point in the distribution system than was traditionally allowed. And if you're able to actively manage those systems at certain points in the year, typically you may be told, no, you can't interconnect unless you pay an upgrade cost or wait for that upgrade to be executed and completed. But a number of utilities are looking at the option of establishing a flexible interconnection agreement where they allow the solar installation says, yes, I'll interconnect now and accept some small amount of curtailment at points in the year to get connected sooner or avoid some costs. And so essentially what this is doing is taking those same ingredients, right, of forecasts passed through power flow models on a continuous basis to say, hey, we expect a constraint either due to, abnormal switching or a very hot day or what have you, and therefore manage some of those inverter settings directly. And so both of those are kind of examples of generating what we would call an operating envelope, but in those cases, self-consuming those operating envelopes. The kind of the piece that I think we could discuss more as kind of the opportunity for these operating envelopes to really free up aggregators or VPPs to participate in that wholesale market while preserving the integrity of the distribution system. And so does that kind of allow them to do their optimization while not adversely impacting the assets? And so what are these? They're essentially bounds on the allowable import or export of power at a given time and location that account for constraints, device capacity, line capacity, voltage. These are expressed as min-max kW limits, potentially kVAR as well, and defined at each asset or group thereof. And they're computed kind of dynamically based on the state of the network for a forecasted horizon. So just a couple of notes on next steps, and it's kind of where I'll leave it. I've kind of hinted at this a couple of times, but I think one of the things that a group like ESIG or others in the industry could really support is the data exchanges needed and establishing what those have to look like. And I know EPRI's already done a bunch of work on this with the kind of TSO, DSO, and integration kind of coordination working groups. But we will need to exchange more data. What aggregators are planning to participate? Where are they located? What assets are in those aggregations? What are their capabilities? Telemetry. So there's a lot more data that is going to be required. And some of this is being established as kind of the filings from the ISOs. This also needs to be established for how that's going to get to the DSO so that they are kind of brought along on that journey and able to kind of engage and take the steps that they want to take forward in kind of the grid services procurement and kind of establishing those. And so what standards will enable this communication to scale across the industry and encourage adoption? There are some existing ones. We don't have to start from scratch. There's the common information model may have some pieces to offer here. There's 2030.5's kind of CSIP in Australia has even started to address some of the operating envelope communication. So there's pieces, but I don't think we're there yet. So more work to do. And then the last, the kind of slide I'll end on is around business model and regulatory frameworks. So, let's say we have the mechanism in place to characterize these requirements and constraints in the distribution system, and the communication is established between the DSO, aggregators, ISO, and customers. What are the rules that they have to play by, and how do they all get paid? How does money move from to the aggregator, or to the utility, or to the customer, et cetera? These are kind of less established than the kind of market frameworks that we see in the wholesale market. So, are aggregators required to observe these limits that kind of via PUC regulation, or does the observation actually deliver from capacity to the DSO? And if so, how is that procured? How is it paid for? If distribution limits are imposed on the aggregators, should they be made whole for not being able to dispatch their entire set of resources or not? And how do customers or consumers kind of move in and out of these different regimes and avoid the double counting issue, but maximize value to both the distribution and transmission systems. So that is all I had. Thank you very much, and I'll pass it along.
Thank you, Dylan. So our next speaker is Dave Maggio. Dave's a principal of market design analytics at ERCOT. Dave's been, I think, one of the ERCOT leads in this aggregated DER pilot program that I think has been very successful, looking at how to integrate these aggregations into the ERCOT region to provide different grid services.
Yes, thank you very much, Eric, and good morning, everyone. I'm here to talk about an ADER pilot, so we couldn't use the same terminology as everyone else. So instead of DERAs, we call them ADERs and not VPPs. But I'm going to talk about a pilot that we have stood up and have started to see some participation in. Before I get into perhaps the more interesting things and looking at some of our observations, I do want to talk about how we got there, because I think that's somewhat interesting in itself. So this really started in sort of the late spring, beginning of the summer of 2022. There was a lot of interest in trying to find ways to get new resources on the grid fairly quickly. And as part of that, there were a couple of our public utility commissioners in Texas who were very interested in trying to get these aggregations of DERs and trying to stand up a pilot. And what was intended to be unique with this is, as designed, these ADRs were intended to consist of aggregations, not only that could change the withdrawal of what was going on, but look to inject power. So not just load augmentation. And that'll be something I kind of touch on a little bit later. As part of that, to give us support and to make sure we had industry engagement, we're getting expertise. This is obviously something ERCOT, as the ISO and our general purview, don't necessarily have as much expertise in. They wanted to bring industry experts to us. So they stood up a task force that involved all sorts of market participants within the region. It actually included folks from sort of outside the region. Erik is a member of that task force. We had some folks from academia. So trying to really bring a broad set of knowledge and try and get this up and running. And part of the reason they wanted all that engagement is they gave us direction to stand up in a pilot in July of 2022. They wanted the governing document that sort of drove how we were going to do that pilot approved by our board just a few months later in October of 2022. And we were able to meet that, but we'll kind of talk about some of the things we had to do to get there. And of course, it took a lot of work, not only from the ERCOT staff side, but the task force and the commission as well. So because of the fact that we wanted to move so fast, I'm going to talk really about, primarily I'm going to talk about a phase one, but there's this total expectation that this is going to be the first phase of several as we look at this pilot. And part of that was because we wanted to move quickly, we wanted to get these resources into the grid, but at the same time, there's all these other priority projects we're working on. How can we come up with something that we can effectively shoehorn into our existing systems, primarily from the ERCOT side, but to some degree as well from the distribution service provider side? So I'll kind of talk about what we did. I'll say because of what we did and having to use the existing systems, this was somewhat limiting, and we'll talk about some of the complaints and concerns that people have expressed. But again, the goal is, what can we learn from what we at least have right now? What are the concerns people are bringing to us? What are some of the technical challenges we see at ERCOT, what we see at the distribution side? What can we actually learn before we actually maybe spend some money and put our money where our mouth is? And one of the things I'll touch on a little bit is, well, I'll wait to kind of come back to that, but again, it links to some of the existing model we have and what it was originally intended for. So to talk about the objectives of the pilot, they're probably pretty obvious. One of them was simply understanding the operational benefits and challenges of having these aggregations on the system and what they can mean for both the transmission system as well as the distribution system. And again, we had a fair amount of experience with this in terms of augmenting load, but what would it really mean if we started to see significant injections into the distribution system? Specifically, we started to see some of these aggregations and the actual premises that are participating in concentration. Along with that, we wanted to understand how these aggregations could participate in providing ancillary services. I know the panel has kind of talked about that. I think that's a key part of the business model that these aggregations are looking at when they want to participate in the wholesale markets. But what do we see in terms of behavior? Are those aggregations there when the system operator needs them, whether that's behavioral or whether we actually get deep into emergency, we actually have to shed load? Are we accidentally starting to shed the customers that are providing our reliability services? What could that potentially look like? Again, talked about this one a little bit. How are we impacting the distribution system? But also, what are the impacts to the transmission system? How can we potentially use these assets to help us manage congestion on the transmission system? And if we do it wrong, could we actually be hurting some of the congestion we're seeing? I know we were talking about the single node aggregations, the sublaps in California. We'll kind of talk about the simplified approach that we took, but what kind of concerns does that raise? And do we need to go the more complicated path of things like weighted shift factors, and I'll kind of talk about that, or these single node aggregations, which could be in themselves very limiting. And finally, again, because we were doing this quickly and doing this in a phase approach, what are some of the problems with the participation model that we're using in this first phase? So can we come up with something else, try to get a broader amount of participation overall in the program? And again, specifically related to that managing congestion, do we have to get into more granular dispatch and settlement as opposed to the approach we took in phase one? So some of the key features, and you maybe think of these as the rules that we had for our first phase. First is that we were largely using our existing aggregate load resource participation model. And along with that, sort of many of the rules, so that what's required in terms of data, how they comply with instructions, they were required to participate in sort of this 5-minute real-time market dispatch. How can they do that smoothly? Really just taking as much as we could from this existing participation model. Along with this was kind of the lesson learned I was talking about. This aggregate load resource participation model was something I think we put into place in 2015, and we never used it. No one ever participated until finally we made use of it for purposes of this pilot. So that was sort of a lesson learned. If we spent all this time, we spent all this money, we prioritized this project, did it probably instead of other things, and we got no participation for 8 years, whatever the case was, until we actually started using it for another purpose. So kind of part of our lessons learned, and we tried to do this better by doing it through a pilot and doing it in phases. Our approach is to trying to leave it relatively open in terms of the scope of aggregation. We do allow it, but it has to be within a single load zone. So that's a fairly large geographic area, but it is a limitation, and it has to be within a single distribution service provider territory. And that's linked more to really sort of the coordination of what's going on in the distribution system. How do we manage that? How does the distribution service provider get some insight into what's going on in their system? Like they talked about in California, we do a process to ensure it's not participating in like programs. So for example, we'll talk about this in a moment, but we're going to allow these ADERs to provide some of our ancillary services. That looks very similar to some of these programs that they could participate in through their electric provider, through the transmission service provider, other programs at ERCOT. So we actually would look to see, okay, you're telling me this premise is part of your aggregation. I'm going to go check to make sure that that's not part of some other program that's similar. Along with this aggregation at the zonal level, we were going to do all our dispatch using zonal shift factors and use zonal settlement. In terms of ancillary services, where we started is to allow these ADERs to provide non-spin service. So this is a 30-minute spin product. Another key feature of it, though, is it has a duration requirement of 4 hours under the current rules, and that's going to be kind of a limiting factor that we'll have to come back and talk about. And then just in terms of size, what we said is, hey, we really want to get a feel for how this is going to work. We have a system-wide participation limit of 80 megawatts and a limit on participation in our non-spin market of 40 megawatts, at least to start within phase one. Sort of moving forward, this is what we came up with in the fall of 2022. We actually did start to see some participation in 2023, and we have actually gone into a phase two. Now that started in February 24. And I have to admit, so far, the changes have been fairly incremental. So one of the big changes was opening up the suite of ancillary services these resources could provide. We opened it up to our ERCOT contingency reserve service. So I mentioned non-spin is effectively a 30-minute spin product. ECRS is a 10-minute spin product. And the other big difference, though, and this is why it was important for many of the folks looking at aggregating, is it has lower duration requirements, being a faster service. So instead of the 4-hour duration requirement that we have for non-spin, in the case of ECRS, it's a 2-hour duration requirement. The primary reason that we did not include this is the fact that when we were developing that first rules, or the first set of governing documents, ECRS didn't actually exist yet in the ERCOT market. That was actually something we just added in the summer of 2023. And so we wanted to actually implement it first, see how it was working, see what the participation looked like before we then opened it up to this pilot. But pretty quickly, we felt comfortable that we could go ahead and do that. And everything else was fairly minor. We found some issues with our telemetry validation processes. Apparently, it's really hard to validate telemetry against the meter when everything is idle on the premise. Comparing 0 to 0, if you know, these really minuscule errors, we were talking about sort of watts of errors, were actually driving them to fail some of our validation processes because they were largely percentage based. So anyway, some really obvious things once you go back and look at them, but we did have a few other little lessons learned that we were able to resolve. All right, so now let's actually get into some of the observations and participation. So we currently have 2 ADERs participating in the wholesale electric market. In terms of size, that's a little over 13 megawatts of energy, and then 6 megawatts each of non-spin and ECRS. And I think I mentioned this a little bit earlier, tied specifically to the ancillary service suite that these resources are participating in, but the primary technologies that making up these ADERs, and really the ADRs that we've seen out there in terms of interest, batteries are playing a key role. In terms of energy and non-spin participation, that began in August of last year, so it did take some time for the aggregators to actually go out and engage customers and set up their systems to be able to meet all the rules of the pilot. And then ECRS participation began in May, just this last month, and that really more a function of, again, that was not included as part of phase 2. Now, one thing to note is, you know, we really have these 2 ADRs now in place since last August, so we're talking about 10 months or so of participation. While the count of ADRs has not grown, the size of those ADRs have grown. So they actually start at a much smaller megawatt level. As they've learned, as they've been able to gauge more customers, they themselves have been increasing in size. So we have sort of seen increased participation in the pilot, even though we've had the same 2 ADRs now for some period of time. In addition to that, we have 8 additional ADERs that are fairly far into the process. We have something called the details of aggregation form. We were talking a little bit about this of, hey, I need to tell the ISO, I need to tell the DSP what is really making up this aggregation. And we came up with a form called the details of the aggregation form that tells me, you know, what type of technology you have, what's the meter, what's the premise, how is it connected to that transmission system. All things that we need to know are all sort of part of this form. So we've had 8 other folks who have submitted these forms showing interest in participating, but they have to kind of go through the process now of getting in our network model, getting their telemetry set up, all sorts of things like that. We do see a couple that feel like they're pretty close, so I'm fairly optimistic by the end of the summer we will see some more participation. In addition, you see that the megawatt quantities are still relatively small. I'm hoping we see something similar to what we saw with the other 2 ADERs. So can they get in with small amounts of megawatts as they're sort of figuring out the technology, as they're figuring out those technical issues? And then can they begin to engage more customers as they're starting to show success and things like that? So I think while the numbers are small now from what they're showing, I think there should be some optimism there in terms of what those megawatts could be. This is just another way of looking at the same data. One thing that, and I won't spend kind of time going through these numbers, but one thing that was important as we stood up the pilot is there seemed to be a couple of entities, one entity in particular that was sort of ready to go to participate in this pilot. And so one of the things that was included as part of the governing document was, one, a limit in terms of how much any individual market participant could take up of those system-wide limits. And in addition to that, putting limits across the individual zones. So taking that 80 megawatt limit, for example, and spreading that across the zones. And really the idea was, can we get diversity in geography? Can we get diversity in participation? And making sure that we didn't see sort of a single technology and a single player sort of taking up the whole pilot. That would be a not particularly good use of a pilot to have. So talking about dispatch, this is focused on phase 1. So it's looking at August 23 through January 24. And this is all looking, sorry, I didn't actually spell out the acronym. This is SCED. So this is our 5-minute market. So these are all 5 counts of 5-minute intervals. Within that time frame, we had a little over 94,000 5-minute intervals to look at. Interestingly enough, more than 60% of the time, these aggregations were making themselves available for online dispatch in some form or fashion. Of that 60%, about 40% of the time, those aggregations were providing ancillary services. So again, that's a fair amount of participation. The next number may be a little bit surprising. When you actually look, okay, how often are these resources dispatched? They participated 58,000 5-minute intervals. In terms of actual intervals that they were dispatched, it's a much smaller number. So it's a 514, so a little less than 1% of all the intervals they could have been dispatched. They were dispatched about that 1% of the time. And there are a couple of drivers for that, and I'll talk about one here and one on the next slide. A key part of this to think about is the offer behavior is probably more similar to what we see in terms of a lot of our demand response. So kind of on the low end, you'd see the offers into the market being in the few $100s per megawatt hour. And on the high end, during different times of the day, you perhaps see into the $1,000 or more in terms of the offer. So that's obviously not a price that we see very often. And so, you would expect the dispatch amounts to be relatively small. So the offer behavior was certainly one component of that. And, how often do you really deploy, again, sort of using the demand bids into the market as sort of a proxy. We really don't necessarily bid or clear dispatch the demand response as nearly as frequently as, of course, you dispatch the generation fleet that you have. The other component, I think, is linked to time of day that we tend to see these ADRs participating. So now this is looking at a count of intervals in terms of when they showed online and available, just sort of averaged across that whole window of time, looking at when they were online available by hour of the day, also when they're providing non-spin, and then lastly, it's a little sliver on the bottom, sort of when they're dispatched. And what you saw is, and which is what we continue to see, in fact, is that they were typically making themselves available during the hour ending, or sorry, hour beginning 6 to about 20. And I think that in my mind that was largely linked to the fact that likely many of these homes that are participating also have solar. So how they wanted to participate had to do whether or not they had excess solar. That being said, one of the things that we were observing last summer, I imagine we'll see it again this summer, is the California duck curve. One of the guys who used to work for me in Texas called it the dead armadillo curve. So you can think about using that terminology. But very similarly, if you look at sort of August and September of last year in particular, when do we see the tightest times on the grid? And then along with that, when do we see the highest prices? And that really is getting further and further into the late evening and early, the early night hours. So kind of when these folks stop participating in the market, kind of would be the time when we may actually dispatch them more. And in fact, it's a small piece on the bottom, but you do see really the majority of the dispatch that we did have was in sort of hours 18, 19, 20, as opposed to perhaps when we had peak load, which was a little bit earlier. One of the other things we looked at, and this goes very much to the first presentation, is, okay, we're going to do these aggregations at the zonal level. We're going to dispatch at the zone. How is that going to impact our ability to manage congestion? And this could really sort of go two ways. If the aggregation sort of spread across the zone in a way that's fairly in alignment with how the load spread, well, maybe a load zone shift factor works perfectly. On the flip side, if they're concentrated, well, that could be a real problem, and the whole sort of fact of moving to nodal markets kind of gets disturbed. So what we looked at here is comparing the zonal shift factor that we had and used to what if we called it quasi-nodal dispatch, but it's a weighted nodal dispatch. We knew from the forms submitted how they were connected to the transmission system. If we look at the electrical bus at the transmission level that they're connected to and do a weighted shift factor using that, how could we do that and compare that to the zonal shift factor? That's complex. It's theoretically a lot better, but is the additional complexity worth it? And what we're seeing so far is not really. So this is looking at sort of a duration curve of comparing the zonal shift factor to this weighted nodal shift factor. We kind of just looked at the top 10% of cases and the bottom 10% of cases. The max discrepancy we saw on the positive end was really only about 6%. So that matters, that could be important. It all depends on the constraint. It matters how big these ADRs become as a participant in the market, but that's relatively small, and that dropped off fairly quickly to something closer to zero. On the negative side, we saw something sort of similar, where really the max delta we saw was about 5%. So, I mean, these are very early. We're talking about 2 ADRs. How will this look different with other aggregations and things like that is to be seen. But at least these are an early indication of, is it worth the complexity? It's hard to justify, at least at this point. And lastly, just kind of quickly touch on what are the things people yell at me about? What are the major challenges that are being raised by the folks who want to participate in the pilot? The big one is following that 5-minute dispatch. That's very hard for folks, and we can kind of talk about reasons why maybe as part of the panel discussion. There's a lot of discussion around the duration requirements for ancillary services. We've had them participate in these 2 services that have 2 and 4 hour duration requirements. That's challenging, particularly when the technology is largely a function of batteries within these aggregations. Tied to the first one is the frequency of communication. We within our current participation model are requiring them to send us data every couple of seconds. That doesn't work if you're pinging your devices every minute. So we've been kind of working with ways to kind of get around that. For example, you can maybe if you can only ping all of your devices every minute, but you stagger when that minute happens, can you sort of smooth out the signal? So those are sort of the things that we have been working through. Lack of interoperability standards, not necessarily an ERCOT thing, but a big topic that's been coming up. And also, we actually have a requirement that the folks who we're settling for the energy are also the folks who represent the ADER. And that's been a limitation for folks who are third parties and want to get engaged. So I'm already a little over time, so I will stop there and save the rest of the comments for the later discussion. Thank you.
Thanks, Dave. All right, so our last speaker is Geoff Ferrell. Geoff is Senior Vice President, Global C&I and VPP Project Business at Sonnen. So I think Geoff's going to give this last perspective of an aggregator or a VPP entity, talking about some of the business models, sort of what their kind of goals are with how to participate in these markets.
Yeah, that's the goal. Basically, as an aggregator, it is taking all this enablement that's happening at the table here from the markets or the utilities and figuring out how to take that to market. So this is a little bit more of a product presentation as opposed to some of the programs and things that are out there. And I'll also preface this by saying that in terms of my perspective, our perspective is from Sonnen as an aggregator, it's philosophically based a little bit differently. I think if we had another aggregator up here, we could have a really cool debate about some of the things that we do. But we very much will take a performance-based approach to tackle some of the things that my colleagues here brought up as challenges and things that are really needed as we move forward. So obviously, what are we tackling here? Energy transition. We're moving towards a more and more electrified grid and adopting EVs, bringing these types of things into homes and businesses and into the distribution system. And how do we prepare the system? How do we make it participative where homes and businesses and grid edge meters, behind the meter assets can be assets and not just be another load, not just be another one-way directional thing sitting on the grid, which is what we're used to. For over 100 years, this is what we're used to seeing. Massive generation, usually far, far, far away from where we live and where we work and where we play, push down big wires to smaller wires to underground wires into homes and businesses, and we consume and we pay a bill, and it works great. Then along came air conditioning, and we broke the whole dang thing. And ever since then, we've been struggling to fix it, right? So we go from air conditioning to more and more electrified appliances. Now we're moving to EVs, and we start to need different types of topologies, different types of relationships to manage these things, to not break the grid, to not need to make massive investments in grid infrastructure, tearing up our streets and parks and homes to run bigger wires, or to need to change out transformers and infrastructure equipment more rapidly because we're stressing it more and more and more. So again, this is a perspective. This is our perspective. Yes, we are a battery manufacturer at the heart of it. But more than that, what we truly believe in is the swarm control, the aggregation, the visibility of behind the meter resources, whether they be large, medium, small, transmission tied, distribution tied, into the grid, edge of the grid tied, behind meters at homes and businesses. It is about visibility. It is about smartening up the energy that we use, not necessarily saying we must shift 100% to solar energy tomorrow. That's not the story. It is about what is the quality of kilowatt hour in the grid right now? How do we best make use of that? How do we embrace lower costs, lower carbon footprints, and transition to cleaner energy with time, smartly using the infrastructure that's already in place and bringing as many stakeholders to the table as we can through things like aggregation. It is one way to allow those folks to be part of the story and part of our future. This is just an example of it to kind of illustrate. I think everybody's probably read. I started to read Bradle and then say read the Bradle report that talks about where we're at and where we need to be. Just an illustration from California. This happens to be one of our larger markets that we're in addition to the great state of Utah that we're sitting in physically right now, that we also will talk about in a minute. So in terms of sonnen philosophy, I'll take a moment here in terms of our VPP philosophy, or what we call the sonnen VPP. I'll leave the pitch there. In terms of what we call the sonnen VPP, we are solely focused on bidirectional energy storage devices behind the meter. That's our story today. We are talking primarily about batteries. We could be talking about EVs down the road, though bidirectional EVs, vehicle to grid, it's a hot topic, but I think it's got a long ways to go. So when we're talking about the VPP and about being an aggregator from the aggregator's point of view, what we're really looking at is what can we do with the assets that we're aggregating? And when you look at these levels of what energy storage as a physical product can be, I will tell you I'm not very interested in level 1 or level 2. When I was a home builder, in fact, in Arizona, we didn't even install batteries for resiliency. Like they weren't hooked up to do backup. It just wasn't important. Our utility there fortunately gave us a very stable grid. There wasn't a lot of need for it, so backup just wasn't our thing. The purpose of installing batteries there, that has now become really the basis for the way our aggregation works through the sonnen VPP, is for grid interactivity. It is for grid use. It is for daily cycling, daily use of the batteries, in some cases more than a full cycle per day, which we can absolutely do. I'll come back to that in a minute. And to really do these higher level things, what we call level 3 and level 4, which are really kind of talking about the value stack where we can bring value to the end consumer, which from an aggregator's point of view, this is our job. It is to take the programs and the structures and the enablement, from FERC 2222 and the great work that CAISO is doing and that ERCOT's doing and PJM and all these folks are doing to allow this type of participation and to create business models where folks want to participate and they want to be part of it and they want to be monetized for these things. So instead, from our perspective, instead of a battery being a sunk cost, like you might have seen from a gas generator back in the day, I'm going to install this $5,000 generator and the off chance my power goes out. Now customers can make a choice and say, I'm going to do a battery instead. And the 363 days of the year that everything's great. And instead I can be offering this to the market. I can be helping create grid stability. So there's less instability, less of a need for the power to go out, brownouts, rolling blackouts, that I would need a backup resource. I can now monetize this thing. It's no longer a sunk cost. It's now an asset. And through some clever management, it can also be a backup resource should that be needed. Of course, the goal is to never get there. Okay, so the way we see it as the aggregator is our value proposition is battery network technology to provide grid services and dispatchable clusters real time via the VPP, what we call the VPP, or what everybody calls the VPP. Lots of debate around that as well. I think I heard from a group a couple of weeks ago that maybe there's the idea of defining things as advanced VPPs to differentiate between demand response products that are VPPs and things that are bidirectional and controllable. I don't know. We'll see. Yeah. I think ADERs are great and just bringing visibility into what you can do with these things. Are they demand response products? Can they provide ancillary services? Are they bidirectional? Do you allow injection into the grid, which is amazing because I think these are really great things that we can do with VPPs that are battery based and maybe eventually, things like EVs if the technology really kind of moves that way. So we as Sonnen, we've been doing this, you're kind of old hat in terms of technology. We've had a VPP around since 2016, which in this industry is almost ancient. Full-fledged services since 2018. Worldwide, we have about 142,000 assets under VPP control. Here in the US, about 8,000, but growing very quickly. A really cool space. We see a lot of value for VPPs to bring value to the ISO to the vertically integrated market, and then to places like ERCOT, that's kind of even like a third model, which is really cool. To be participative, to provide those data intervals. So one of the things that I'll go into here before we kind of go into some of the models to show you the things that we've done is that they need to act like the distribution and transmission system are used to other things acting. They're used to getting telemetry and reliability and these different types of things from power plants. And if we want to really affect energy transition, and we really want to be part of the story, it is on us as aggregators and is on the programs to mandate that the things that come onto the grid be capable of the same level or similar level of participation and visibility. Otherwise, what happens is, and we've seen this for years, is you have to start to devalue or to scale back the confidence level in that asset. So if you bring 100 megawatts of something to the grid, but it only gives you 5-minute interval data, or historically you're only seeing 60% participation, you now have to value that thing at 60%. So you've overbuilt infrastructure once again, but then what the confidence level is to the market, to the grid, to the operator is 60% of that. That's less than ideal. You know, we're not getting to the top of the curve. Whereas I think if you look at, and I'm not an expert, so I won't throw a number out there, but if you look at something like a power plant, that number is much, much higher. You know, yes, they plan for downtime. Yes, there's resiliency in there. You know, they've got other things like resource adequacy to cover for that. But we see it as our job as the aggregator, as a performance-based aggregator, to make sure that what we bring is optimized in terms of confidence and availability and the data that we can provide. So for example, we provide 1-second interval data. It's ridiculous. Nobody would ever want that. AWS loves us because we buy lots and lots of data from them, storage space from them, but it's silly. But it's necessary in some cases. It's a really great thing to have if you need it. We show 4-second full power responses for most of our assets. That's really, really valuable when you're talking about spin and non-spin, when you're talking about frequency regulation up and down, voltage regulation up and down, which we do here in Utah. So to be able to bring assets with that level of efficacy and telemetry and to share that data, which Dylan highlighted really well, there is going to be a need to share a lot more data, to do it in a very secure way and to do it in a way that makes sense so we can make better and better decisions, including things like weather forecasting and forward-looking models. So I'll leave that there. A couple of quick examples just to kind of baseline what we think we know so far. There's obviously a lot we don't. I think we're all figuring it out together. So compared to some of these other presentations, I will admit this one's maybe a little bit haphazard. Really what our job is right now as an aggregator is to take all this, distill it down, figure out what these models look like, figure out what we can pay our customers to join, inspire them to join, and really aid adoption. I will tell you right now that my team is a gigantic red line in Sonnen's ledger, and I'm okay with that. We spend money, we pay people to join these programs, and we'll figure it out later. It just is what it is. What is important right now is getting assets on the grid. What is important right now is developing these models, to being communicative with our utility and ISO partners to understand what works and what doesn't work, and to hone in on models that long-term really do create value for all the stakeholders involved and can carry forward and can move into future phases and go from pilots to full-fledged programs. So where this started, I kind of alluded to it earlier, started in Arizona. This is a home builder in Arizona, mostly on APS's grid, a little bit of SRP. But really where this started was not a VPP. We call this VPP Lite. What the utility did is they created a really cool rate plan that enabled smart right-size solar tied to battery, and then use of that battery for consumer benefit. And really what they were saying was, we'd like to give you some really simple price signals, very difficult to react to, but really simple price signals that help the grid out broadly. And it basically said, you can consume power all day long. In fact, we'd love if you consume some power from the grid all day long, because we have it swimming in the grid and we'd love somebody to buy it, please, for the love of Pete. So it was 4.5 cent power during the day. And then when you went into peak period, they said, okay, you can continue to have 4.5 cent power, but if you have any demand whatsoever, we're going to charge you a demand charge. So APS, to my knowledge, was the first utility that came out with a residential time of use demand rate plan. It was really cool. And it led to a patent, actually. So what we did is we developed a patent with Mandalay Homes that basically said what it would do is it would actually charge off the grid a little bit. So these homes had very small solar arrays. That picture in the bottom left is a 3,200 square foot house in Phoenix, and that's 12 panels on the rooftop. That's all this house had. That really offset about 30% of the home's annual load, because the goal was not to just pack it full of solar and inject solar into the grid. That was already happening. APS didn't need that. What they said was, we would love for you to soften the blow, but actually take a little bit off the grid. So we developed an algorithm, basically would use solar first. It would trickle charge off the grid during the day, saying, when do I need to get to 100% state of charge so I can discharge against peak? And it would take as little off the grid as gently off the grid all day long, based on what was going on with the weather, with the solar, with the loads, to get that battery charged, and then discharge fully against the home's load all during the peak period until it was dead. And that led to a pretty cool patent that we now call the patented, well, it is patented, time of use algorithm that we use in all of our VPP aggregations today. So that led to Utah. I don't know if you guys knew this before you landed the other day, but you happen to sit in the largest utility-directed behind-the-meter aggregation of batteries in the nation. Rocky Mountain Power has a little over 4,000 residential batteries throughout the state of Utah and Idaho right now that form up a program that they call WattSmart, that is actively dispatched every day to help them combat their duck curve, to optimize some really cool wind that they generate up in Wyoming, and to incentivize their customers to be participative in the grid of the future. That is operated as one of our aggregations. This is a pretty unique model because it is a vertically integrated model. Their goals, their signals, the way they operate are very much different than maybe the way California would operate, or ERCOT, or an ISO model, but it is a model that we've developed some expertise in and do really interesting things every day. So we are providing frequency response. We are providing resource adequacy, voltage regulation. We do a classic demand response every day with these batteries. We also do net injection from a couple of the contracted systems down in Harriman, Utah, as well as, and this is my favorite thing of all things, we actually do on occasion reverse demand response. So we'll actually get a signal from Rocky Mountain Power's ADMS that says, hey, we've got excess solar, we'd love a place to shove it. Can you guys take it? And the aggregation will receive that signal, will then put that into customers' batteries, and they've worked out a system, a way within their rate tariff to compensate customers for having done that, so that it doesn't rack up as kilowatt hours on their bill. So that's a pretty cool use case that can go into other, I think we kind of touched on some other presentations, if we can figure out the billing aspects of that at the distribution level, at the retail level, that holds a tremendous amount of value, and customers would be really excited to be involved in that. Whoa, I'm not showing that slide. Sorry, that was way too small print for you guys. I think we're sharing the slides afterwards. This is a really great one. This is basically just a value stack of all the things that we're doing here in Utah that we're capable of doing in all the markets that we aggregate in when regulation allows it. So spin, non-spin, we've talked about that. Dispatched swarm grid charge, that's the reverse demand response. Providing resiliency, of course. We can do resiliency at the home as well as resiliency at the grid level, whatever that looks like. Daily cycle mitigation of the duck curve. This is really just kind of responding to a time of use rate plan, of course. Frequency response, energy products, capacity planning, classic demand response, load shedding. And then in aggregations like we have here, we have an example of this here in Utah, non-wires alternatives, where we have 4.5 megawatts of energy storage tied to about 8.5 megawatts of solar. And we're able to show the value, some non-wires alternatives value of harnessing that solar through batteries to prevent additional upgrades and controllability where the utility didn't need transformer upgrades, wire upgrades to enable that community to be built out. Probably the most salient for this conversation would be this third aggregation, which is what we call Sonnen Connect California. This is our participation in CAISO. This was basically our entry as a product, as an aggregation product into a marketplace. So kind of value proposition, again, our goal is to aid adoption, to get people in, to get them paid, to get them to want to do this, instead of just solar alone or putting a generator in the backyard. That makes no sense whatsoever. So kind of the tenets of these types of programs are the proactive time of use bill management, where we're helping customers minimize their utility bill. Important aspect on this is at the same time, this is also coincident to helping the utility save on their costs, because it creates a more predictive load pattern, as we talked about earlier, a more predictive curve, day to day, year to year, that can be planned and accounted for better. Dynamic VPP grid services, again, as an aggregator, we are moving meters in and out of programs to meet the grid's needs and to generate as much revenue for the customer as possible. When those are coincident, that's great. If not, we make some choices and make sure that our customers are still beneficiaries of that while doing the right thing for the grid. Proactive backup power, this kind of goes to some of our weather forecasting, or PSPSs, if we're signalers of PSPS, or we see inclement weather coming in, we'll actually shift batteries into proactive backup mode, so that customers do have that benefit of using their battery, monetizing it in California 364 days of the year. And then that one day of the year, things go crazy, they have backup if they need it. And then, of course, proactive service and fleet monitoring. This is mostly for our benefit. Again, earlier, like I said, the way you get the most out of these systems is to make them available more hours, to make them effective to the grid planners and operators, so they know that if there's 10 megawatts of something sitting in a plan, that they can call on 10 megawatts of that. So it behooves us as the aggregator to make sure that our assets are available as many hours of the day or of the year as possible for everyone's benefit. Quick example of what this looks like in California. Essentially, under NEM 3, this is a NEM 3 model, we're able to show as much as an 85% reduction in a customer's annual costs of electric energy with right-size solar. I'll tell you, this is less than 100% annual offset. Right-size solar plus battery in a Sonnen Connect aggregation, and then monetizing those dynamic as well as the bill savings. I think I will leave it there because I'm out of time, and I do want to make sure that we leave time for